Everyone, and welcome to the Extending DevOps Practices of SQL Server Databases webinar that is sponsored by Redgate Software. Today, myself, Steve Jones, and Arneh Eskandari are here. We're going to hopefully go over some things that will be of interest to you, help you kind of streamline your development and get going. For those of you who don't know me, I'm Steve Jones, and I run SQL Server Central. That's where a lot of people know me from. I founded that site about 15, 16 years ago, and I do that as part of my job today for Redgate. I also work for Redgate as an evangelist, and so I travel around writing and speaking about SQL Server and Redgate tools and doing community work. The contact information is on the screen. I've been working with SQL Server software and SQL Server itself since 1991, so I've had 25 years working with the platform and a variety of big and small companies in different industries. And so some of the things we talk about today are things I've been doing for years, and they're kind of wrapped up in this DevOps moniker, but they're just great practices that have really helped many companies I've worked with develop software very smoothly and quickly. So hopefully you get something out of it. Arneh, I'll let you introduce yourself as well.
Sounds good. Hi, hey everyone, I'm Arneh Eskandari, and I've been with Redgate for almost 6 years now. And as part of my role as a sales engineer, I work very closely with our sales team on the technical side of things, so helping our customers getting up and running with our DLM solution, as well as reviewing their existing processes, making recommendation on best practices, and also post-sales implementation and training as well.
All right, thanks a lot. So here's our agenda. It's there's a bunch of stuff here. I'm going to try to get through the first number of items fairly quickly. Again, we're recording this webinar so you can catch up with those later, but we really want to spend most of the time on demo if we can do that. Now, a few housekeeping items. We are recording this, and we'll get this up on our YouTube channel, and I believe everybody will get an email later on this week when that goes up, along with a link to the question and answer. So any of the questions you asked, we'll collate and put those together and get those posted so you can look at the answers to all the questions at your leisure. If you do have questions, there's a little questions panel in the GoToWebinar control panel, so please feel free to ask those questions. We will try to get to those as much as possible, but there's a lot of people on the line, and we're trying to cover a lot of stuff, so we may actually have to take some of those offline and get those up later. And then I think that's about it, so let's get going. So as we mentioned, both Arneh and I work for Redgate Software. Redgate has been around since 2001, about as long as SQL Server Central, and at Redgate we really build tools to help you build software. So we use these simple, easy, intuitive tools that are designed to help you more easily build SQL Server software, manage SQL Server databases, work with .NET software. And our tools are used by tons of companies all over the world, big and small. Lots of professionals do that, and we're proud of the fact that lots of people like our tools. But it's not just that we want to sell you software. We also try to make sure that we give back to the community. At Redgate, we believe we're part of the community, and that's one of the reasons that Redgate sponsors myself and Grant Fritchie to go around to different events. We sponsor events separately, but we go there to speak. We also provide SimpleTalk and SQLServerCentral.com as community services to just help you get better at your job. So we really believe in being part of the community in addition to just being a software company. So there's challenges in trying. Yep.
Just so you know, I just ran the poll to see, what percentage of our attendees are familiar with Redgate and which tools. So, looks like 30%, almost 40% have voted. So, yeah. So please keep voting, and then we'll go from there.
Oh, okay, yeah. So all these tools that are up on the poll, we're going to show you. I think almost all of these or most of these today, but you're welcome to download evaluations from the Redgate.com site and give them a try in your own environment and see how they work. So
yeah, exactly. So far, yeah, looks like the majority of people are familiar with SQL Compare, which is not a surprise. There's a good percentage on SQL Source Control, which is really good as well. So as well as SQL Monitor. So okay, great. So I'm going to go ahead and stop that now.
All right.
And we can go ahead and continue.
Excellent. Thanks, Arneh. So for SQL Server, or really any database platform, that has code involved, it can be an impediment to the DevOps process. And really it comes down to the fact that for tables, we have to preserve state. We have to make sure that as we roll out changes to our database platform, we have to keep that data around. Right? If I could drop tables and rebuild them all the time, make my life much easier for deploying code, but I can't. Now for some of my code, my views, my store procedures, my functions, methods, modules, anything else that I've got on SQL Server or other platforms, it's very much like C# or Java or Python or other code where I can deploy old and new versions and kind of just change them left and right. Now, of course, the application still has to work, the logic has to work, but I can change versions easily. With tables, I actually have to kind of modify these and enhance these while I keep the existing objects around. So that becomes a little bit challenging sometimes, and we have to consider that. Oops. Now, if you do this kind of an ad hoc manner, if you try to figure out deployment by deployment, what I need to deploy, how do I build the scripts, how do I make things work, you start to have all these issues that I see on the screen. So the main one is the common complaint from most developers and companies these days is that databases become an impediment and they slow down the application development. They get out of sync with what I'm trying to do with application development. There's also the ability of trying to understand what I'm changing or not changing, what's going on, how do I get, what's the previous version if I need to go backwards. That just becomes a problem. The big one for me is the 1, 2, 3, 4, 5, fifth one down there. So releases tend to be less frequent and more risky when I do them manually. When I'm not using a DevOps or a more modern process, then every release starts to cause some stress. We have to put it together. It takes a lot of time. It's inefficient, and it becomes risky. And because of that, we tend to delay them. We try to be very careful about when we release, which means I pile up more and more changes. For all of us work in technology, I think we know that the more things that we try to change at one time, the more likely that A, something will break, but B, we won't know what caused the breakage. So the idea is that we want to try to avoid some of these deployment effects when we're just doing this kind of manually or ad hoc. Now Redgate, we've kind of coined the database lifecycle management term, which fits with ALM, application lifecycle management, to say that we're trying to put a process together for how we manage our database development and database deployment. It's not trying to be heavyweight, we're not trying to be difficult, it's not something that should slow you down. What we're really trying to do is make all of your database development and deployment repeatable and reliable. Those are really the goals here, that we want to ensure that anything that can be handled by a computer and automated, we want to do that, because humans are poor at repeating manual activities the same way over and over and over again. At some point we'll just make a mistake. So we want to try to make these repeatable and reliable. Part of the way you do that is to try to make small units of change. So because I can make deployments whenever I want and I'm comfortable with how they work, I can make small deployment changes as I need to rather than stacking up a lot of changes all at once. The other thing is I can gain reliability by incorporating automated testing. I don't want to belabor that too much. We'll show a little bit of testing, but I think testing really becomes more and more important, and many application software developers, whether that's Java or C# or something else, they started to understand that having unit tests and being able to regression test all of my code is very valuable and very helpful to ensure that I can produce higher quality software. Now Puppet Labs runs a state of DevOps report. They run it for a number of years and they get thousands of responses. It's been growing and growing every year. And these items that we've listed or bulleted here are very similar to what they've seen in the past years as well. And the number one item that they found, that organizations that seem to be very efficient and work very smoothly in developing software, they really use version control. That's usually the number one predictor of whether or not a company exceeds the average in terms of being able to evolve, enhance, change their software without problems. Version control just seems to provide that base that allows you to tell what's going on in your software development process, and so that's kind of the core of what we do here as well in databases. We want to make sure you're using version control. Now the other thing is that these companies become more agile, not using agile software development or Scrum or anything in particular, but they have the ability to change their code as they need it. That might be that they deploy a change once a month, but then as they find issues or they realize problems, they could deploy every day for a week to make sure that everything's fine, or it could be companies like you read about in much of the media, like Amazon and Facebook and Etsy, that deploy hundreds or thousands of times a day. It just becomes their ability to do so is because they incorporate a good process. And the other big one, at least for me as a database person, is that their change failure rate, how often a change causes a problem and they have to roll it back or undo something, is much, much lower. And then the last one is a big one, typically for business people, is that we become more profitable when we can be agile, we can respond quickly. We don't have the case where somebody asks you to make a change, you spend a week, 2 weeks, 3 weeks making the change, getting it tested, takes a few more weeks to deploy it, and then a month or two down the road we realize I'm really not going to use that change. It's frustrating for me as a developer when somebody doesn't use something I've built, and it's just a little bit annoying that I've spent time doing something. By being able to make changes quickly, I can get that change into the hands of the end user quickly, and they can decide, do we want to continue with it, do we need to enhance it, do we need to do something different, get rid of it. I learn all of that stuff very, very quickly. So how does Redgate help with all this stuff? Well, really, what we want to do is show you in the demo the software development process, and so I'm trying to get through this quickly. If we look at the top of the diagram from left to right, we're going from development to operations. So from development to automated processes, then we move to intermediate environments such as QA or testing or staging or UAT or beta or whatever environments you have. Eventually we get to production where we have operations, DBAs, sysadmins that have to watch things. The Redgate has a number of tools that plug in at various points, and we try to plug into a variety of platforms and be fairly agnostic towards whatever platform you want to use. So if I break this down slightly, in development, developers can work on their own databases or shared databases or however they want to do it. They can include application code or not include application code. But the idea is we want to make you more productive with things like SQL prompt and SQL source control, and we want to ensure that you're getting that code into a version control system. And we don't care if you use TFS or Git or Subversion or Mercurial or Perforce or Vault or CVS or anything else, SourceSafe even, will help you do that. And really what we're trying to do is capture that code that you write in Visual Studio or Management Studio or Notepad or Sublime or whatever you tend to use. We want to capture that code and get it into version control. And then we want to implement continuous integration. This has dramatically improved the quality and speed which application developers can work. So we want to do this with the database as well. We want to take that code, we want to be sure that it's syntactically correct, that all our references are there, that nothing is broken. We assemble that up. We want to be able to run tests. So we provide SQL tests for developers to run your tests in SSMS, but we want to run an automated system to ensure that all the tests that need to be run are run every single time. And again, we're platform agnostic. If you want to use TeamCity or TFS or Jenkins or Bamboo or Cruise Control or Go or Hudson or whatever, we'll work with all of those. And then we have a DLM automation suite that allows us to plug into a release management software. And release management software is just designed to ensure that software can get deployed and installed on other platforms. I've seen a variety of these packages across the years. Most of them are kind of very proprietary and difficult to use, and not to mention expensive. But these days, with things like Octopus Deploy and TFS Release Management, these things are very simple to use. They're flexible. They don't lock you in. I can deploy my database code alongside my application code. I can push stuff to clients. I can do mobile code. I can do a huge variety of things. And all these software packages do is allow me to script it to deploy in a certain way. This means that when I make my database changes, I deploy them to test or QA, I can see how that deployment goes. And if I have issues, I can fix it. I'm not counting on it going to production. I can include other environments like UAT or staging, and I can deploy there as well and continuously practice this deployment so that when I go to production, I'm confident that my code works, that it accomplishes a task it needs to, but it's also not going to break something. And then, of course, at Redgate, we've got some tools to help you monitor this once you've gotten it to production. So, and also, just to keep in mind, it pops up. We want to make sure that you get the correct deployment script and it's available for you to look at, so we'll see how that works in a minute. So we've got a demo we want to do, but first, I'm going to make some changes. You ready, Arnie? Hopefully he's ready.
Let's do this.
All right, so I've got this table. I'm actually going to make a change here to this table, and you'll see this. So I'm going to make this change, something simple, nothing big. I've got a few comments in here. I'm going to copy these because I'm going to use these in a second. And then I want to alter the stored procedure, so I'm going to add this where clause that doesn't exist in the stored procedure in there, so let's execute that. So I've made my changes here on my local system. This is my .SQL 2014 instance. I've got this database, and you'll notice that I've got some changes that have occurred here. That this is SQL Source Control checking my changes in here. I can see both of these changes I've made. I'm going to stick comments in here, and I'm going to let Arneh explain this a little bit better, but for now I'm going to commit these changes. It doesn't matter. We're going to let those go. And you'll notice I've got a push change here because this is Git. I'm going to push these out to VSTS, which is going to go out to somewhere in the Microsoft Cloud. And now I am going to switch this over to Arneh, and he's going to show you how all this stuff really works.
Excellent. Thank you, Steve. All right, so let me share my screen first. Okay, so as Steve mentioned, we're working with Visual Studio Team Services, so the cloud version of TFS basically, to collaborate. So Steve just made some changes, and he pushed his changes to our Git repository in VSTS. This is basically how our folder is structured. So when you link your database to source control through our SQL Source Control plugin, it goes ahead and creates this folder structure for you. So there's a subfolder for each class of object, and within these folders we store the create scripts of those objects. So we store the state of your database in source control as opposed to the individual change scripts that you write to make your changes. So in our repository, we are actually currently working with two branches. So we have a dev branch and a master branch. So Steve just made some changes to the dev branch, and he pushed those to the dev branch in our VSTS. So now, as the other team member, I'm going to make some additional changes and push those to dev as well. The workflow is that once we're ready with our once we're ready to deploy our changes, then we'll go ahead and merge our changes from dev into master, and that's what will trigger a build in VSTS, and then we can deploy from there to our higher environments as well. So I'm going to go ahead and start making a couple of changes. Obviously, when you're working with a team, the first thing you need to do is to make sure you do a pull from the remote or whatever branch you're working on to make sure that you're including the latest changes that were made by other developers into your local repository. So to do that, you have different options. So if you're working with our SQL Source Control tool, which is what you see here in SSMS, it's a plugin to Management Studio, acts as a bridge between your development databases and your existing source control system. So in this case, it's Git. If I look at my setup, you can see it's currently linked to my local repository. So each developer links their database to their local repository, make changes, push them to the remote so other developers can pull and make some additional changes to the database. So in order to do a pull, you have a couple of options. You can use our Get Latest tab and pull from the remote repository, as you can see here. Or you can even use a specific Git client tool, such as SourceTree, or even the Git command line. So whatever you're comfortable with, you can just continue working with those tools in our solution. So if I do a pull, you can see it says there is one commit to pull. So I can do a pull here to my local. And so that way I can update my local repository to include the latest changes, which are, in this case, are the changes that were made by Steve. Okay, so we can see we did a pull into our local repository. So here's the changes that came from Steve Jones, as you can see. Now I can go ahead and make my changes to the database. So let's say we want to modify, a store procedure. So I'm going to go ahead and modify the store procedure. I'd like to add a couple of columns to the select statement here. So let's say we want to do organizational level and national ID number. Okay, and I'm going to format this using SQL prompt. Okay, happy with these changes. Go ahead and make the change. So I'm also going to make a data change to one of my lookup tables. So another benefit with SQL source control is that you can source control data in your lookup tables, your reference tables. So and it's really easy to link those tables to source control. So you can go to your other SQL source control tasks and link or unlink static data. And this will show you a list of tables that you have on the database. And from here, you can select the ones that you want to source control in terms of data. So in this case, I actually don't have any data linked to source control. So I'm going to go ahead and link contact type to source control. So that way I can keep track of data changes that I make to that table. And now I'm going to go ahead and also add a new record to that table as well. So using SQL prompt snippets, insert into contact type. And I'm going to create a new contact type, and I'll call that an MVP. All right, so made a couple of changes here, made a schema change to an object as well as data change to a lookup table. So I'm going to go ahead and commit these changes to source control. So right-click on my database, commit changes to source control, and let's see what happens here. All right, so so here you can see the two changes that I made. So modify the USB get employees and the contact type data. The first thing you notice is that it shows a conflict between USB get employees that I just modified versus what's in my local repository. So it looks like there is a change that I pulled down, which was a change that Steve made, that I didn't have on my object when I made these additional changes to the object. So for that reason, it's showing that there is a conflict. Now, with conflicts, you can either just keep your copy or take the other developer's copy, or you can even merge changes. In this case, just to keep Steve happy, I'm going to merge my changes with his, and then update source control to include both of our changes. So to do that, I can use a diff tool such as kdiff, and I can go ahead and merge those here. So the first one that I want to merge is, so let's say we want to keep the comment that Steve has put in, and for this part, I want to keep mine, so I'll select A. And for this part, I want to keep Steve's change, the where clause, so I'll select his. So this is, at the bottom, you can see this is the merged version of the store procedure that we're looking at. So everything looks good. I have my new columns in there. I have Steve's where clause and Steve's comment in there as well. So everything looks good. I'm happy with this merge. I can go ahead and save this.
Thanks, Arnie. Thanks for keeping my changes in there.
No problem. Okay, so I did that merge. I'm going to close it, so that way I can go back to SSMS. So now it's going to recompare, make sure, show us the new changes. Okay, so in this case, you can see now we have the where clause in there that I merged from Steve's change, and all we're doing now is adding the new columns to it. So everything looks good there. On the data side of things, because this is the first time we're committing data from this table into source control, we're putting all the records from this table into source control, including the last one that I just added here at the bottom, the MVP one. So I'm going to select this, and I'm going to write my check-in comment. So linked static data from contact type table and modify the USB get employees struct. Okay, so as you can see, I'm currently working on my dev branch. So we show you what your current branch is, so that way you don't make a change to a different branch by accident. So I'm going to commit these changes to my dev branch, and then we'll merge those into master in order to trigger a build in our CI environment. Okay, so go ahead and commit this to dev. Okay, that went through. Again, I can push my changes from here, from my local to the remote, either through the user interface of SQL source control. So you can see here it gives me a push option, or again, you can use source tree to do your pushes as well, or the command line of Git or any other Git client tool that you might be using. All right, so the first thing I want to do is I want to update the remote branch for our dev environment. So I'm going to go ahead and push this to dev. And once that's done, then I'm going to go ahead and merge the changes that we made into our master branch. So, you know, we're ready to push our changes to the next environment. So the first thing we need to do is to merge the changes into master, and then that will trigger a build in our CI environment. So I'm going to switch to my master branch. Okay, so here you can see there are two commits that are ahead of master. So I'm going to go ahead and merge these into master. Okay, so here are the changes that came from Steve. I want to merge those. And here are the changes that you know, I made. So I want to merge those as well.
All right, so while there's a merging, Arnie, and you're going to push, let me just pop a poll up so that we can see. We'd like to know what source control systems you all might be using. So are you not using anything, or using Git or Subversion? You know, we're just kind of curious because it helps us determine, you know, where to focus our work and better understand what we can teach you guys or help you get better at using the system. So a lot of TFS, which is good because you know, when we push that up to visualstudio.com, is that TFS 2017 now, Arnie? Is that what?
It is, yeah. So VSTS is based on the latest version of TFS, which is 2017. Yep.
Okay, good. All right, so looks like 2/3 of the people are using TFS, so that's good. So let's close that off, and you can keep going then.
All right, awesome. So you can, so in this case, we just made changes to our database, right? You could have both your application code and a database inside your repository, and you know, we actually had a question from one of our attendees earlier on about how do I, you know, make changes to both the application code and the database, and make sure that the right versions from each of those you know, the application code and the database code are going together to the next environment. So the idea there is to use a branching merging strategy similar to what we had here. So we have a dev branch here. You could have a feature branch instead, where, you know, developers or individual developers are working on a specific feature. That could include the code from your application as well as the database script. And once you merge those into your master branch or your release branch, that's when both the database changes and the application changes will get built and then ready to be deployed to the next environment. But in this case, we've just made database changes, and that's all we're focusing on as part of this demo. So I'm going to switch back to TFS. So if we look at our build and release tab here and look at the builds. Okay, so here you can see we had a build that just ran, build number 19, and that build was completed successfully. It was based on the latest commit, the 9.3b, which is the latest commit that we merged into master, so everything looks good there. The build was successful, but what I'm going to do next is to show you what we've done as part of this build process. So for VSTS or TFS, we offer a set of extensions that you can use as a plugin to include the build steps for your databases. So if you go to the Visual Studio Marketplace and search for DLM Automation, you can see there are two extensions offered by Redgate that you can use. The first one is the build extension. So this is specifically used for building and testing your databases as part of your CI process. The second one is the release extension, which is used for deploying your database changes from source control up to your higher environment. So I'm using these two extensions in VSTS to do my builds and the deployments for the databases. So just to quickly show you my build step. Okay, so this is what my build definition looks like. I just have one step in there called database build. What this step does is that it tries to create the version of the database that you have in source control or in your master branch on a temporary database to make sure that your database can build successfully from scratch and to make sure that there is no broken dependencies and no SQL Server compilation or syntax errors. So once this build succeeds, then we go ahead and package up the files from source control, so all those create scripts and insert scripts for data that you saw earlier into a NuGet package, which later can be used as a source of deployment going to our higher environment. So that's all we've done as part of our build process. I could use a publish artifact step, but our extension automatically does that under this option here, so I didn't need to add an additional step to publish artifact. As part of our extension, you also have some additional steps that you can use. So for instance, you can test your database package using T-SQL-T tests. So T-SQL-T is a unit testing framework that you can add to your database and write some unit tests for your database. So they're basically a set of stored procedures that you can add to your database and start writing unit tests for it. So they look like this. So you can see I have a bunch of stored procedures under the T-SQL-T schema, and you can use these objects to create a stored procedure for your database and run those tests automatically as part of the process. We also have another framework that we use as part of the same process called SQL Cup. Similar to .NET Cup, this is a code analysis testing framework to make sure that you're following best practices, you know, when scripting out your objects or naming your objects and different types of tests, as you can see here. So if you're using any of these two frameworks, then you can utilize the automated test step in our build process to run those tests automatically. You can also use the sync function. So the sync function is useful for cases where you have an integration database or a central dev database that contains everyone's changes, and you also have individual databases that your developers are working on. So when you merge your changes into master and that build succeeds, then the next thing you want to do is to update the main shared development database to include the changes that came from the master branch or whatever branch that you were working on. So you could use the sync function to do that. The sync function could be used for deployments as well, but since we have the release functionality within TFS, then we're not going to use the sync function to deploy to our higher environments. We're just going to stick to the release workflow for that. So these are the steps that you can utilize as part of our extension to run builds on your databases. Now, since our build was successful, I'd like to go ahead and deploy our changes to our next environment. So I'm going to switch to the release tab of VSTS. Again, these same extensions are available for on-premise version of TFS as well as VSTS, and the workflow is exactly the same. In fact, I'm using a local build agent set up on my machine to do the builds and the releases. So even though it's VSTS and it's in the cloud, you can have a local build agent running, you know, those tasks from a local server and submit the results back to VSTS.
Hey, Arnie, hold on just a second. Let me run our poll on CI real quick before you get there.
Sure, sounds good.
So if you're using CI, we'd be curious to know, or if you're not using it as well. And then there were a couple of questions. So Arnie, somebody asked, why did my changes appear in SSMS when you made your changes? You know, why was there a conflict there when you had gotten the latest version? You know, so when you went to
really good question.
procedure, you didn't see it.
Yeah, so really good question. So one thing I forgot to do, it was to, once I pulled the changes to my local repository, I had to do a get latest on the get latest tab here to apply the changes that I pulled down to my local repository to my my development database. So that was really the main reason why it didn't show up on my database. So it was me forgetting to hit apply changes to my local database. But the good thing was that the conflict was caught when I tried to commit those changes into the process. So I still had a chance to merge the changes that Steve made to my database and then apply those changes back to source control.
Great. And then one other quick one. So somebody asked, can you bundle database changes and application changes into one change set when you commit them?
So so it depends. So typically with Git, when you're writing, when you make a change and you commit, you can, I guess you can make both the application change and the database changes to subfolders within the same repository. And then when you go to commit, it will show you the changes made to both the application code and the database code under a single commit or a Git hash, specifically if you're working with Git. So if you're not working with Git but you're working with TFS, that is the centralized version of TFS, not the Git workflow, then what you would have to do is you would need to save those changes to your workspace first, and then use Visual Studio or Team Explorer to commit both the application code changes and the database changes together under a single change set. So that would be the workflow using those two options.
All right, let's keep going.
All right, great. So I'm going to go back to, so quickly I'm going to show you the build log from the build, which is something I forgot to do. So again, you see our build was successful. You can see exactly what version, source version or commit, triggered the build. And you can see the associated work items and the associated changes. So you can see there are some changes that came from Steve Jones, some changes came from Arneh. So all of these were built successfully on the build database. So now I want to go ahead and release those changes out to our next environment. So I'm going to create a new release. Okay, so we're taking our latest successful build to deploy. So it's going to take the NuGet package that I mentioned earlier from this build and compare that NuGet package against our target environments to see what's different, and then generate the deployment script based on that comparison that it does. So while the deployment is running, I'll quickly walk you through my build steps for this specific release definition. So let's go ahead and edit. Okay, so as you can see here, I've broken down my deployment into 3 different steps. The first one is called Create DLM Automation Release. What this step does is that it runs a comparison between your NuGet package and the target environment to generate the update script. Once that script is generated, then we add a manual intervention as the next step for a DBA or whoever is responsible for doing deployments to review the update script and the changes that are going to that environment. If they're happy with the changes, then they can approve them, and then it will continue on to deploying the update script that we created as part of the first step onto our target environment. I'm going through the same process for all of my environments. For staging, I actually have one additional step, which is deploy from database. What I do for this environment is to make sure that the schema of my staging environment matches my production environment as a pre-deployment step, and then go through the same steps that we saw earlier on. And for production, again, it's going through the same 3 steps again. All right, so I'm going to go back to my releases, and here you can see the release to my testing environment has stopped, so it's pending a manual intervention. So I'm going to click on that, and it says review the changes.html report in this directory. So the directory could be on a network share or somewhere in the server. So I'm going to go to that directory here, look at the testing. It's release number 8, and open up the changes that HTML report that was mentioned in the instructions. And here are the changes that we are pushing through. So you can see there's 3 different changes that are being deployed. It shows you what type of change it is. So are you modifying or altering an existing object, or dropping an object, or adding a new object? In this case, we've modified existing objects. So if you look at the sales.commission table, it looks like a new column was added. So this is the change that came from Steve. If you look at the get employees store procedure, it has the changes that I made as well as the changes that Steve made to the same store procedure. And finally, the lookup data from the contact type table that is basically which only shows one difference, which is that new MVP contact type that I added to this lookup table. Everything else is identical between our source, which is the NuGet package, and the target, which is my testing environment. You can take a look at the warnings. So it says this deployment adds a column to the table as not null with no default value specified. So a couple warnings here that just to let you know what type of changes are being made and how they're going to impact the deployment. And here is the deployment script that we are running. So you can see here is the alter procedure to the store procedure, and here is the change that it's making to the table. So one thing that it's doing here is it looks like it's trying to create a temporary table, copy all the data and the new column to that temporary table, and then drop the old table and rename this table. It does this for specific type of changes. So Steve, did you? So it looks like you added the column as not null.
Yeah, I did, and well, I thought I added it, but maybe I did an alter there. Let me.
Yeah. So I'm assuming because there's no default value.
Yeah, so it's making that change that way. So I would have had to code that differently to do that. So
yeah,
not a big deal. There's not much data in there.
Yeah, exactly. So, but did you? But since there's no data in there, I think the deployment will fail, right? If we try to deploy the change.
No, it should work. It should work because there's no data in there. Yeah.
Oh yeah, you're right. The table is empty, so that should be good. Okay,
yeah.
Sounds good. Yeah. So now, since we're talking about this type of scenario, so typically when you add a not null column to a table, you obviously want to put some default data if that table does have some data in there already. So you could utilize our migrations feature of SQL source control to override that default behavior of compare, trying to create a temporary table, copy all the data to that temporary table, and then rename that table once it's dropped the old one. We could just simply provide a migration script for that type of a change and say, instead of you creating a temporary table, I just simply want you to add this column as null, run an update to update it with some data, and then change it to not null, and provide that script as the script that compare would need to run. So you could utilize our migrations feature to override the default behavior of compare for those type of refactoring changes that you made to tables. There's 2 types of migration scripts that you can write. So there is a data-only migration script. So if you want to do data fixes to your higher environments, you could provide those as blank migration scripts. Or if you want to override the default behavior of compare for specific schema changes, then you would use the bottom option here to replace uncommitted schema changes. All right. So we can go ahead and approve these changes in this case. So go ahead and resume. Now it's going to take that update script that we just reviewed and execute it on our testing environment. Okay, while it's running, Steve, are there any questions that you think we should go over at this point?
There's a couple things, but let me run this poll on release management real quick, and then we'll go forward from there. So
Sounds good.
there is a question on the data. So they asked about us moving the data across, and you showed that all those contact types are going to be moved along into build and release, right?
Yeah. So because the only difference that existed between the contact types in source control and the target environment was the MVP, then the MVP record is the only one that is getting inserted into my testing environment. So even though we just committed the data from that table to source control for the first time, but when it ran the comparison, it noticed that a lot of the data from that table already existed in our target environment. The only one that was missing was the MVP one that we just added. So it's only doing an insert for that record into my testing environment. And you can see everything is part of the same deployment script. So and by default it runs your deployment script as a single transaction. So that way, if something doesn't work or your deployment fails, then it will roll back the transaction to the beginning, and it wouldn't leave your target environment in an inconsistent state.
Right. And then so somebody's asking about .NET application code and database changes want to be released together for deployment.
Mm-hmm.
And this person is using Jenkins, but it's the same process here. So maybe you talk a little bit about that, about if you had .NET code in this repo as well in this workspace.
Yeah, sounds good. So if I go back to my code real quick, let me show you my repository. Actually, just let me show it on my local real quick. So I'm going to show you my local repository, my Git repos, Git. So in my local repository, currently this is how my repository is set up. As you can see, there is the subfolders for my database objects, right? If you had application code and database code, then I would structure this repository slightly differently. I would have one subfolder for app code, one subfolder for database, and then within the database folder, I would have these subfolders. So that way you can keep your application code separate from your database scripts within the same repository. Once you have that folder structure, then you can, when it comes to the build side of things, then you would basically just set up a single build definition, which would have, an MS build step for doing the application code, for building the application code, and then as well as our database steps to do the database build. So you can build both your application code and the databases together under a single definition. In Jenkins, it's the same. It's no different. So we have plugins for Jenkins again, similar to the extensions that you saw in TFS. And in Jenkins, you can also run MS Build for your application code if you're working with .NET or any other programming languages. I'm sure there are plugins for different programming languages that you can use to build your application code.
So if you go to the release tab real quick, let's just show them. And if you go to the release definition, so let's just do an edit here. You have with this thing. So Arneh's got in here just the steps. For the testing environment, he has 3 steps, right? He has the creation, right, the manual intervention, and then the deploy. But you could add another task here that said deploy an ASP.NET website, right, or something else.
Exactly. Yep.
So if you look, you see here, he's got all these tasks from the Visual Studio default build or deploy area, but there's tons more in the marketplace that you could do to deploy mobile code or anything else, right? And you would just add this as another step. So that would do that.
Yep.
What else? So somebody's asking, they've got a situation where they have software developers that are building on branches. They're doing database work, but then they've got a database where they have, it looks like, a BI team that's actually making changes there, so they want to only do certain changes out to that BI database and not overwrite what the BI people are doing. So, I mean, I think that seems like more like something you just need to manage in source control.
Exactly right. So you would still need to keep this separate under branches. So the BI team if you just want to basically deploy and build the changes that you make to the database, then you would create a branch, either based on your team or based on feature or whatever makes sense to you. And then you would only commit your changes to that specific branch, and then you would merge build the changes from that branch. So that way, what you put in source control doesn't include the changes that came from the BI team. The main requirement here is to make sure that you're always building and deploying from source control. And if you have the right branching set up in source control that helps you keep your work separate from another team, then you can easily build what you put in source control as opposed to everything that has been made to that database.
Right. So somebody asked about configuration provisioning with something like Ansible or Chef with the Redgate integration here. So I haven't ever tried to use Chef with, Chef deploys the state of the system, right? And it
the
deploy
configuration, right?
the DLM piece on top of it. But the build release piece would still be separate in your build or release software, right? Which Chef isn't really doing the build and release of the software. It's just defining
exactly
how you want things to look.
Yeah, exactly. Generally, I'm on the same boat as Steve. I'm not too familiar with Chef. All I know is that it's used for deploying configuration changes to your servers. But the rule of thumb is if you can use PowerShell in any on any platform or any of these automation tools, then what we offer as part of our DLM automation is a set of PowerShell commandlets that you can use to write those steps using PowerShell as opposed to having to use a plugin. So our plugins are just a wrapper around those PowerShell commandlets that we offer. So if you can write a PowerShell step in any automation tool, then you can utilize our database steps as part of that as well.
Right. Okay, and I don't see anything else in the question list, so I think that's about it. Let me flip back over to mine.
Sounds good. Yeah, I was just basically doing the deployment to the staging environment, which is basically going through the same process. It's now pending that manual intervention. And the good thing with TFS and manual intervention, for those of you who are running the on-premise version of TFS, you would need to use 2017 in order to get the manual intervention steps as part of your release process. Currently, it doesn't exist as part of TFS 2015. So, but it's a good way to introduce a gate to an automated process where someone will have the opportunity to review the changes that are going into the hire environment. So, yeah.
Okay, so let me flip back and show my screen. Just one thing I just wanted to show. So I've got this repo here where I do some of these demos as well. And I've got a Hello World application. So I've got a C# application here. And then separately in the same repo, I have my scripts folder. And so one of the things is I can do build and release of either the application or the database or both together. And it's just a question of configuring that in TFS to say, hey, I want to commit this stuff and send it out. So it works, but it just depends on how you've scripted it. Now, if you want to get more information, we've got stuff on the redgate.com site. You're welcome to go to solutions and see more about that. We also work with some partners to do training. So if you go to the /training link, there's online training actually, so you don't have to attend any training, but we have some partners that will certainly come to your organization to do training as well. And then we have consultants that are happy to help as well. And please email us if you've got questions again. Now, we've recorded this, and so I expect that this will be available probably by the end of the week, but everybody should get an email. So look for that. It'll have the recording as well as answer the questions. So I think that's about it. Thanks, everybody, for joining us. I think I've got one more question I want to answer here, but then we'll call it a day. So thanks, Arnie, for the demo. It looked great.
No problem at all. Thank you.
All right, and everybody have a great day. Arnie, feel free to stop the recording now.